Hello class. So in this video we're going to evaluate trigonometric functions. I'm actually going to do all 6 of them rather than just part of them. Alright, so let's first talk about the Sohcahtoa thing. So the first thing to keep in mind is to pronounce Sohcahtoa correctly, because otherwise then it's not going to be spelled this way, and that's the point of it. So sine of theta means the opposite side of theta divided by the hypotenuse. That's the O over H. Cosine is adjacent over hypotenuse. In other words, the side that's adjacent to theta divided by the hypotenuse. Tangent is opposite over adjacent. The side that's opposite of theta divided by the side that's adjacent to theta. Alright, in terms of symbols here then, we have that sine equals the opposite, which is y, divided by hypotenuse, which is 1. In other words, sine is represented by just the y value in the unit circle. Unit circle. Similarly, we get the cosine is the x value in the unit circle when you look at the coordinates. And then tangent is going to be opposite over adjacent, which is y over x. Cosecant, secant, and cotangent are just reciprocals of each of those. So if you understand what the word reciprocal means, which just means you get a fraction, you flip it, then it's very, very easy to see that cosecant is just 1 over the y value in the unit circle. Secant is 1 over the x value, and cotangent is just x divided by y. It's literally just each of these things flipped over. So if you can get one of them, you can get the other. It's really easy. So let's work on that then. Okay, so sine. When we have sine here, basically we're going to look for the y values at the coordinates. So what are the coordinates at 0? The coordinates at 0 are 1, 0, right? So where are the y coordinates? 0. Cosine x coordinate. So here we have 1, so cosine of 0 is 1. Tangent is y over x, 0 over 1 equals 0. Okay, so not too bad, right? And I suggest right now to have your unit circle just like out so that you can reference that. I have the points memorized because, well, I teach the stuff. But yeah, so for pi over 6, we have square root of 3 over 2, comma 1/2. Y value is 1/2. X value is square root of 3 over 2. So I'm just going to fill out sine and cosine first, and then from there we're going to get everything. 1 over square root of 2 for both the x and the y here. Pi over 3, our y value is square root of 3 over 2. Our x value is 1/2. For pi over 2, our x value is 1. Y value is 1, x value is 0. And then, because of the fact that the unit circle, like if we look at the pi over 4s, same exact triangle over here. So same coordinates, right? Pi over 3s, same coordinates. Pi over 6s, same coordinates. So these are actually just going to repeat in a very interesting way. So the y coordinates for 2 pi over 3 are going to be the same, exactly. And then the x coordinate is just going to be negative of that. So the sine, you can just like reverse going this way and you get the same exact coordinates. Cosine, same thing, except they are negative. So that helps. And I notice that you're basically going to have the exact same thing going even further than the next part. So we might as well just do that. And then we'll just fill out tangent, these ones, and then do the other one a lot quicker. Because we'll have seen the pattern already. Okay, so 1/2 divided by square root of 3 over 2. If you do that out, you'll get this I'll just show you. So that's very easy to do. Don't overcomplicate it. It's literally just fraction over fraction. Multiply numerator by reciprocal of denominator. You've heard that year by over year over year over year, so just know it. And then you get 1 over square root of 3. Remember, you do not have to rationalize. No one in mathematics actually does that. I'm just going to fill these out a bit quicker. Just because I don't want the video to last way too long. Because, I mean, we're just doing the same exact calculation over and over anyway. I just want to highlight 1 over 0 is undefined. Dividing by 0 gives you undefined. Alright, cosecant, secant, and cotangent. These are easy to do as well, because you're literally taking the sine value, flipping it. So for cosecant, let's just do that column by column. So cosecant, let's take all of these, flip them. If you flip 0, you get undefined. So you can write that down here as well. And then you get 2, then you get square root of 2, and then 2 over square root of 3. 1, 2 over square root of 3, square root of 2, and 2. Same thing with secant and cosine. Let's just flip those completely. And then you will get all of these values. And then cotangent and tangent, again, same thing. You just flip all the tangents and you get your cotangents. And then if you flip undefined, you get 0. Because that was dividing by 0, now it's 0 divided by something that's not 0. Whoops, looked at the wrong column. Alright, so we get all these. I suggest taking a picture, copying it down, look at patterns. We'll go over patterns a little bit later. But the basic thing is what we already said. 0 to pi over 2 is going to be a certain thing, and it's just the exact reverse of it going on after that for sine. Same thing with cosine, it's just you got different positives and negatives going on in different places. Alright, so here... Actually, I guess we can talk about a few quick things first. At the pi over 6's, sine is always going to be a half somehow. That means cosine is going to be the other one, which is square root of 3 over 2. Reversed, exact reverse at pi over 3's. And then at the pi over 4's, they're both 1 over square root of 2. If you know these, that will help you get everything else. Because everything else is just a reciprocal or a division or something related to sine and cosine. So make sure you see and understand that pattern. Use that to your advantage. Now let's go to the next one. Okay. So you know you're going to get 1/2 at these somehow. And then square root of 3 over 2. We'll worry about the positive and negatives later. Got 1 over square root of 2's. And then you got these going on. And then for 3 pi over 2, the coordinates for that are going to be 0, comma, -1. So we got that. And this thing going on. All right, now let's get tangent. Oh, wait. We got to get the positive and negatives first. These are in the third quadrant where both x and y are negative. So that's all negative. And then over here, these are all in the fourth quadrant where only the y value is negative. There, easy. All right, let's get the tangents. So at the pi over 6's, you're always going to get 1 over square root of 3 somehow. And at the pi over 3's, you're always going to get square root of 3 somehow. And then at the pi over 4's, you're always going to get some sort of 1. And then at the pi over 2's, it'll be undefined because you're dividing by 0, right? And then at the whole number of pi's, it'll be 0. So notice these patterns, use them. Use them. Alright, so what's negative? these are all positive because you got negative over negative, and then these are negative. All right, let's flip them then. And I'm just going to do this fairly quickly. By this point, it shouldn't be too hard to see the pattern. If you need to, just review the video as many times as you need to until you understand the patterns. Again, don't memorize. That's going to make your life a lot harder than it needs to be. But if you see the patterns and you use the patterns, you will reduce a lot of the memorization and actual work that you need to do with trigonometry. And it'll help you just understand it better overall anyway. And okay, now I'm done with this. Don't have to think of random things to say anymore. All right, so these are all of the trig values for the trig functions. In the next video, we're going to actually use these to graph all of the functions here. Again, you will see a lot of patterns there. Know the patterns, use the patterns. I can't emphasize that enough. So yeah, patterns.